All right. So the one we're going to use is f of x equals x minus 3 squared. And then we're going from 1 to 9 as our restricted domain into 4 subintervals. Okay. So what we use is this, the limit as n approaches infinity of n I equals 1 f ui change in x.
Yes. Quite literally a for loop.
Okay.
Delicious.
So the reason why they use this is called this is the Riemann sum. What this is technically your height at whatever f you're finding. Remember yesterday we did f of 1 and f of 2 and f of 4 and f of 6. This is just the height of your rectangle. This is the width. Now remember yesterday our change in x was different. It was like 1, 1, 2, 2 because they partitioned it differently. And then they have here n approaching infinity. Why do they have n approaching infinity? Because you want to be able to put the maximum amount of rectangles in the world. Because if I can put an infinite number of rectangles, I'll get an accurate area, right? If I subinterval it into like 4, then I'm not actually making the largest area possible, right? So when we go to do left, right, and midpoint Riemann sums, they're all going to be set up the same. If they wanted in this notation, we're not going to do it to infinity. What are we doing it to this one? How many rectangles are we making in this example?
4.
We're making 4, right? So we want n to be infinity if we're actually doing the integral, because we want to make an infinite number of rectangles and find the area of them. Yeah.
So if the FUI just is the height and the delta slash triangle slash whatever x is just the width, why do they use so many different variables for those two simple concepts?
Because this is the general formula. We're going to fill in actual values right now. So what we are going to do is we're not going to do the infinity one because the infinity is just the integral symbol, right? We are going from I equals 1 to how many?
To 9. 4.
To 4.
Right.
Because this was an infinite number of rectangles and we're doing 4 rectangles, right? Now, what f are we going to fill in to get our height? What is our formula that we're going to fill it into? F of x. I don't know why I made that bracket so darn large. I'm going to get a little aggressive on the bracketing. F of x. Our f of x is this, right? And then change in x. Change in x is the width change. So change in x is just b minus a divided by n. Well, what the heck is that? Change in x is my largest minus my smallest. So what's my largest x I go to? 9. And I'm going to subtract 1. And then how many rectangles am I cutting it into? 4. So it's just 8 divided by 4, which is 2. So the width of every rectangle I have on this one is going to be 2, 2, 2, 2. Yesterday's, it was 1, 1, 2, 2 because they partitioned it not evenly. They did do 4, but they gave you the partitions, and they can do that on the AP exam. So my change in x here, I can write as a change in x. But now we're going to actually fill in the values for it. So we get 4 I equals 1, what is f of x? X minus 3 squared. And what is change in x? 2. So that's if they use the summation notation. Yeah.
What's the op?
Well, it would be this would be xi, sorry. Because you would fill it in for there.
No, like the I under the, like I equals 1. Like what's that?
That's where you're starting at. You're going from 1 triangle to 4 triangles. And by triangles, I mean rectangles. 1 rectangle to 4 rectangles. Now, I'm just showing you the summation notation because they can give it to you. When they ask me to do right, left, and midpoint, I just literally do area 1, area 2, area 3, area 4, and bypass the whole summation massive mess. But they can give you a question with summation, and if I didn't show it to you, you'd be like, what is this fancy E with this fandangled I and some weird numbering things? And they could ask you things.
What's the S? Oh, summation.
This thing? Yeah.
It's a what? No, it's a 4.
It's for some, but yeah. If I didn't speak of it, though, you'd be like, what's this fandangly E? Except if you're Nathan, you'd be like, it's the Greek S for some. But, okay. All right. So if I go to use the formula, it is f of x equals x minus 3 squared. Now, we know that the change in x is 2. We've already figured it out. And it's because we take the 9 minus the 1, which means we have 8 x's between, and we're dividing by 4, so they're going to be every 2. Okay? And I would hazard you to actually sketch the graph from 1 to 9. So I'm going to do that over here. Now remember, we're cutting it into, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 1, 3, 5, 7. Why am I only writing those numbers?
Those are the rectangles.
That's where we're going to have, the rectangles hitting, whether it's the left or the right. Yeah?
How do you know those are the 4 rectangles?
Because you're starting from 1, you're going to 9, and it's cutting every 2.
Oh, you didn't say that. Do you just assume that it cuts every 2?
No, we did it right here.
Oh, that one, okay.
So I'm going to find the values of those so I can sketch it. Because if they take away my calculator, it's the only way I can do it. 1 minus 3 squared, which is 4. We get aggressive, just so you know. Okay, f of 3 is 3 minus 3, which is 0. Then f of 5 is 5 minus 3 squared, which is 4. Why is it going 4, 0, 4? This is a parabola that's been moved what? 3 to the right. So my vertex is on 3, 0, right? That's why it is where it is. Okay, f of 7 is 7 minus 3 squared, which is 16. And then f of 9 is 9 minus 3 squared, which is 36. And that's why I stopped drawing the lines, because it's going to get stupid. Okay, so there's a real gap here. That's a bit of a problem. We'll just pretend it's there. So we have 1 and 4, 3 and 0, 5 and 4, 7 and 16. 4, 7 and 16. 11, 12. Here. And then 9 and 36 is right here. So we have something curving relatively like that. Did I do left or right first? I can't remember. Left. So oh my gosh, why do I want to say triangles so bad? How many rectangles are we going to make?
Four.
4, because it said,
1, 2, 3, 4.
yeah, and it said to cut it into 4. So, and Peter can count, so that's good. It said to cut it into 4 subintervals, so we're going to have 4 rectangles. Now, if I'm doing the left-sided ones, I'm going to use this, and this to make my rectangles, right? So I'm going to go up to this height, over, down, area 1. Then I'm going to go, whoa, I need to go over a little further. Why is it? Okay, what is the area of the next one?
0.
Yeah, it's going to go like this. Then the area of the next one, I'm going to go here, over, down. And the area of the next one, I'm going to go here, over, down. So am I overestimating or underestimating on this one? Under. So this would be my area 1, this would be my area 2, pretend it's the line, area 3, area 4. Okay? So if I want to do left, what's my width? 2. Is that ever changing? No. What's my length? I'm doing area 1.
4.
It's 4. Because we're going to use this one, this one, this one, and this one, right? What's area 2? 2 times, what's my height of 3? Yeah, so f of 1, is 4. F of 3 is 0. F of 5 is 4. F of 7, 16. F of 9, 36. Do I care about F of 9, left Riemann sum? No, because that would be the left side, right? So I'm going to do 2 times 0 for area 2. And then area 3 is going to be 2 times what? 2 times 4, 2 times 0, 2 times 4. And then 2 times 16. Another way they write it out is they'll go, what can I take out of all of these? Well, actually, we'll go like this. 2. And then instead of writing 4, they'll write f of 0. Why did I write 0? F of 1. And then this would be 2, and then this would be f of 3. 2, and they'll do this ahead of it, like before this one. F of 5, 2, f of 7. Because we're picking the left ones. This step is often written before this one, just so you know. Just proving a point. You know what I mean? Like they could write it that way. They could also take the 2 out of the whole thing and write it this way. They could write it like this. 2 f of 1 plus f of 3 plus f of 5 plus f of 7. Why can they do that? So 2 in every term, they can just GCF it out. Okay? So it's faster. Either way, we end up with this. This is where we want to end, right? That's where we want to be. And that gets us 8 plus 8 plus 32, which is?
48.
48. But we know 48 is grossly what? Underestimating. Then 2. Two is right Riemann sums. What changes with the right one?
It overestimates.
It's Not always, but in this case it will overestimate just because we have a concave up parabola. If it was concave down, we do the vice versa. Vice versa. So how we could write this one out is we want to take all the right-handed ones. So we would technically have this. Then we would have this one. That would be my area 2. This would be my area 3. And then this would be my area 4. Oh, that's really not drawn at 9. This is my area 4. Pretend that should be, yeah. So it's going to be a lot more. So the other way you can do it without drawing it, you know how I'm sketching it every single time? You don't actually have to sketch it every time. You could just do area 1 is 2, but instead of using F1, I'm now going to use F3, F5, F7, and F9, right? So if I'm doing left Riemann sums, I'm going to use F1, F3, F5, F7. If I'm using right Riemann sums, I'm going to use the right-handed ones, so F3, F5, F7, F9. So when you're doing left and right, you're never using all 5 of those F's, right? Because that would make 5 rectangles. We can't make 5 rectangles. We have to make 4. Does that make sense? To everyone? So you can sketch the whole thing you want if you want to and use your values that way. Or you can say, hey, if I'm doing left-bounded ones, I can only use 4 of these. So I'm going to use F1, F3, F5, F7. If I need right-bound, I'm going to use F3, F5, F7, F9. Okay? So I'm going to do 2 times F3 plus 2 times F5 plus 2 times F7 plus 2 times F9. So I'm going to get 2. F3 is 0 plus 2 times 4 plus 2 times 16 plus 2 times 36. So I'm going to get 0 plus 8 plus 32 plus 72. Now some people like taking the 2 out because then they can just go 4 plus 16 plus 36 and then just multiply it by 2.
What are you saying?
He's just saying you can take a, no. Well, yeah, but no. Okay, so we have 40 plus 72, which is?
112.
And we are doing what this time? Overestimating. We can see how much extra area, I'm going to bring this right back, but we can see how much extra area the green is calculating. Yeah, this one is the only one it didn't, but then these, it's overestimating.
I did 32 instead of 56.
So we know, instead of drawing a whole graph, we could just draw a number line. We know we're going 1, 3, 5, 7, 9. If we're doing left, we're picking 1, 3, 5, and 7. If we're doing it this way, if we're picking right, we're picking 3, 5, 7, 9 for my Y's. What about midpoint?
The average.
The average of them. But we're not picking those ones. We're picking their midpoints. So we're going to actually use 2. And that's in the middle. 4, 6, 8. That's what we're going to use for our heights. Does that make sense? So left Riemann sums, we use the left hand first 4. Right Riemann sums, we use the last 4 because they're going to be the ones from the right. Midpoint, we draw out a number line, and we're going to use the actual ones in between. I'll show you what that looks like on a graph. So on the graph areas, it would look like this. Okay, I'm going to take this height over. This is my new rectangle. I'm going to take the middle height right here, over. I'm going to take the middle height right here, over. And then the middle height followed up here, over. So yes, I'm overestimating its spots, but I'm also underestimating, underestimating. So we're hoping that they would balance, right? Will midpoint be perfection? It could be if like your line was exactly perfect and there was exactly above and below, exactly above below, exactly above below, right? Other than that, it'll be better, but it doesn't have to always say it'll be perfect. So the midpoint area, we're going to go 2 times f of 2. I haven't found any of these yet. Plus 2 times f of 4. Plus 2 times f of 6. Plus 2 times f of 8. I need to find those. F of 2 is 2 minus 3 squared, which is negative 1 squared, which is 1. F of 4 is 4 minus 3 squared, which is 1. F of 6 is 6 minus 3 squared, which is not 4, it's a 9. And then f of 8 is 8 minus 3 squared, which is 25. So I get 2 times 1 plus 2 times 1 plus 2 times 9 plus 2 times 25, which gets me 2 plus 2 plus 18 plus 50. 72? So here we had, I'll be right back, left 48, right 118, midpoint 72, so it kind of falls in the middle, right? How do we find the actual one? Well, we are going to go, what?
Integrals.
Integrals, true statement. So we are going to go area equals the integral from 1 to 9 and what was our equation? F of x dx. Will we write it like that though, or can we put f of x in it? 1 to 9, what's my f of x? X minus 3 squared dx. Now, what we're going to do is we're going to do the fundamental theorem of calculus. The catch, though, is we have to be able to actually find the antiderivative of x minus 3 squared, which is complex right now because it looks like a chain rule, right? So I'm not going to use x minus 3 squared. I'm going to use its best friend, the distributed version of x minus 3 squared, because that's way easier to do. What was going to be x squared minus 6x plus
You say your best friend isn't yourself. Oh, it is.
Okay. Quiet, please. So, what the heck does this mean? It just means if I find the antiderivative of this, I can plug in the 9 and plug in the 1 and subtract them, and I actually get the area between. So, what the heck does that mean? Well, we know that when it follows behind with a dx, that this is a derivative. That's all it's telling me. It's telling me this is a derivative. You know what the other dead ringer of this is a derivative? This is an integral. There's two things saying, I'm a derivative. Okay? So when we move forward with our derivatives, we get increasing, decreasing, we get maxes and mins, we get points of inflection. When we take a derivative, or we take a graph, and we actually find the antiderivative of it, it'll give us the area under the curve. So, what is the antiderivative of x squared? Well, it would be x to the 3, and then it would be 1 over 3. Yeah. Minus 6x to the squared, x to the squared, divided by 2, plus 9x to the 1, divided by 1, technically, plus c, and then we do this. square bracket behind it and say it's from 1 to 9. Because that's how we do the square bracket behind it to say, okay, it is from 1 to 9. If I had just an integral symbol like this, it was just an integral, say it was like this, off to the side, I'll show you. Like this, my answer would be 1/3 x squared minus 3x squared, minus 3x squared plus 9x plus c. That would be the answer. Because it's an indefinite integral. There's nothing defined. I'm not finding the area between anything. This is like a general solution. It's like, if you now tell me to find the area between 20 and 70, I can fill in 20 and 70, right? But that would be the answer to this. When I have it, that's an indefinite integral because it's not defined. This is a definite integral. I want to find the area between 1 and 9. Okay? What do we do next? We just fill in. Whatever's on the top comes first. Subtract, fill in whatever's on the bottom. That's it. That's all we're going to do. So to get the area, we just go 1/3 9 cubed minus, this is a 3, minus 3 9 squared plus 9 times 9 plus c bracket minus exact same thing with a 1.
No, I'm talking.
Oh, I was waiting. I was listening. I'm a good listener. 1/3 1 cubed minus 3 times 1 squared plus 9 times 1 plus c. 81 divided by 3, 27? Must be 27 minus 81 times 273.
243.
243. I was really out to lunch there. Plus 81. Now this is the thing. This C and this C cancel. Why? Yeah, you'd actually distribute the minus sign all the way through, right?
Nathan said you did something wrong.
Yeah, I don't think 9 cubed.
I divided it by 27. I meant 240. This one's 243 too?
Yep.
Awesome.
That makes sense. Yeah.
Yeah. It's just reversed. And then we get 1/3 minus 3 plus 9. Not sure why I'm showing all the work, because you at this point just took me. Okay. Now, 224 divided by 3 is what we want. They could ask for it as a decimal. What would we put it to unless they make rounding rules randomly on like 4 questions? 3 decimal places. So we would have 74, you'd go approximately, sorry, you'd have a squiggly bracket, or a squiggly equal sign. 74.667. So this is the actual area. It's pretty close to the midpoint, but it's not exactly it. Now some might say, well, what if we can get the actual area that easy? Why the heck are we getting the possible area this way? Because they're showing you the ways that they worked through the math till they got to this. And they can ask for it, so that's also why we're doing it. And it's in the curriculum. It's a crazy thing. Okay? So those are the 3 ways they can ask that. Does that make sense? Where you get midpoint, left Riemann sum, right Riemann sum, and then definite integrals. Definite integrals are not hard. The hardest part is a definite integral is literally getting just the derivative of that. And the great thing about us is we can only do power rule reverse derivatives or like e to the x's, like things that were really basic where you can just undo a quick derivative, or integration by parts and substitution rule, which we haven't done yet. Okay? Now, I want to show you something. It's just area under the curve. And remember, in calculus, I have to teach you the calculator methods because in AP it's in the actual curriculum. So can you type that x minus 3 squared into your y equal? Okay. So if you typed x minus 3 squared into your calculator, did everyone do that? Okay. The new ones can do it in a different way. The old ones can do it in a different way. We're going to go second. Calc. We're going to calculate something. Is there anything on there that looks like it would be helpful?
7.
Number 7.
That's crazy. 1.
Lower limit is what? 1. Enter. Upper limit? 9. Enter.
Whoa.
Answer's the same. Now there are some of you, if you have the newer calculators, Peter, you are not this person. If you have the newer calculators, TI-83s for sure don't. Some TI-84s don't. That's why I think I can look and see that you for sure does.
It doesn't let me enter the number.
So if you have a fake one, yours probably doesn't as well. So you're going to go, Nathan's is out. You're going to go math, and then you'll arrow up to the one that looks like it. You guys can figure it out. If so, yours would be number 9. You just have to look at. There's like a. You'll find this interesting. YouTube can look. It gives you the function on how to type it in.
The documentation.
I think it's like the equation and then the lower comma, lower bound, comma.
Oh, because you have it.
So you guys are gonna pick number 9,
Did you get it?
and then you're gonna just type the sequence. This is what theirs looks like.
It took me a minute.
Like it looks like it.
I know, because I read it. Yeah. Because when I put in the secret
Okay,
draft,
F
like.
bar bar A B total. That's the.
So you do math.
Empty.
Wait, I don't think it's text. Did you get that? Yeah.
I love online documentation.
Did a thing.
It's a great thing.
You got the original.
Oh,
And you.
okay.